Lesson 39 is area under a curve. This will be, not the way we're doing it today, area under a curve will be an application of integrals eventually. Okay, like derivative is slope of a tangent line. Integral is area under a curve. Okay, that's an upcoming application. For today, we're looking at the basics of doing this by hand and estimating area under a curve. So when we look at area under a curve, you'll notice at the top it says upper and lower sums, left, right, and midpoint sums, all depending on how the directions are given. So, the front page I believe is upper and lower. The back page is our left, right, and midpoint sums. So example 1, use lower sums. So note it specifically says lower. It's always going to have to dictate what type of sums they want you using. So use lower sums to estimate. This is just an estimate, it's not giving us exact. The area under the curve, y equals x squared plus 2 on the interval from 1 to 3. So that's saying from where x equals 1 to where x equals 3, divided into n equals 4 equal subdivisions. So we're going to be looking at the graph, y equals x squared plus 2. We're going to be looking at the area under it. And so when we say area under it, generally that's defined as the area between the curve and the x-axis. Okay, so that area there, specifically from where x equals 1 to where x equals 3. So it's not like infinitely, it's in that assigned range. If that is divided into 4 pieces. Okay, and we're talking today, and what we're doing, we're talking rectangles. Taking and filling rectangles in those spots. So, okay, first things first. We need pictures on this stuff. Okay, so we're going to draw a picture of specifically the area we're talking about. What is x squared plus 2? A parabola? Up 2. Yes? So I'm going to draw, and all I'm going to draw is that parabola move up to. All I really need to know is that first quadrant shape. Does that make sense? Because this section we're doing is from 1 to 3. So over here on the right, I'm going to draw my first quadrant. And yes, I don't know that I'm making it huge, but I'm making it decent size because I'm going to have to put some details on this. So here's my 2, going up 1, 2. So if it's a parabola, I'm going to try and, maybe not exactly the right shape, but again, I need space to show what I'm doing, okay? So I'm trying to enlarge, zoom in on this one section. And we have to be able to look from 1 to 3, right? So obviously here is 0. I'm going to break this 1, 2, 3. So we have our curve, y equals x squared plus 2. The interval 1 to 3. So that means, so you guys see what I'm going to, from 1 to 3. See those vertical lines I've drawn in? I'm trying to find this area right here. I want to know the area from 1 to 3, from the x-axis up to this curve. I would kind of shade it in, but I'm going to be drawing rectangles in, so I don't want to, This area over here from 0 to 1, that's irrelevant. Okay, that has nothing to do with this problem. That's just, I kind of needed that to help draw my picture. Now, it specifically says to draw this into n equals 4 equal subdivisions. So right now, from 1 to 3 is how long? That is too long. If I divide that into 4 pieces, how wide is each piece? A half. Officially, that was a pretty easy one to do just logically. Officially, what you would do to find that is subtract your endpoints, 3 minus 1, divide by how many you're trying to divide it. So 3 minus 1 is 2, and 2 divided by 4 becomes 1/2. And And so each equal subdivision is 1/2 wide. So that means we're going to have a subdivision starting at 1. We're going to have a breaking point at 1.5. We're going to have a breaking point at 2, at 2.5, and at 3. Did I end up with 4 pieces? And it says equal subdivisions, meaning in width. Obviously, they're not going to be equal in height. That's not possible. They're equal in width. So here's our 4 subdivisions. Now, this specifically said lower sums. And I guess I mentioned earlier, these subdivisions that we're going to be looking at are rectangles. Right now, they're not quite rectangles, are they? They've got 2 parallel sides, they've got a flat bottom, but the top, they're not rectangles. We're going to make those rectangles because, can we do the area of a rectangle? Yes. Yeah, we can do the area of a rectangle. This shape with the curved side, it's trapezoidish, but yet it's a curve still. It's not a straight line, so we can't do that area exactly. And remember, today this is an estimate. This is not an exact area. So lower sums means that my rectangles are below the curve. And when we draw these rectangles, they always, one corner of the rectangle is on the curve. So lower sums means, for instance, I'm going to draw the top of a rectangle there. It happens to be going from the left side. I'm going to draw my rectangle here. I'm going to draw my rectangle from 2 over and from 2.5 over. So these are lower sums because all of my rectangles fall under my curve. And one side or the other of the rectangle is a point on our curve. Does that make sense? Okay. So what we basically have to do is find the area of each of these 4 rectangles and add them up. Easy enough? It's really not bad, I promise. How do we find the area of a rectangle? Okay. Area of a basic rectangle, length times width. What do you know? What do you want me to call it? The width? What do you know about the width of all these rectangles? They're all 1/2, aren't they? What about the lengths? Or it's kind of like the height here. How am I going to be able to find out how tall this rectangle is? And how tall this rectangle is? And this one? And this one? Are you just guessing on those? Because I kind of disagree. Okay, so the idea is the height of the rectangle is determined by the curve. This right here is a point on the curve x squared plus 2 when x equals 1. The height of this rectangle is determined by the equation x squared plus 2 when x is 1.5. At 2 and at 2.5. And in this problem, 3 doesn't matter. Okay, so first of all, remember, my equation, yes. Okay, so my equation is f of x equals x squared plus 2. And I'm using f of x so I can plug in the numbers. So I need to find f of 1 because that's my first point. F of 1 is 1 squared plus 2, which is 3. So that's one number I need. Then I need to find each of these, right? Yes, I'm writing them out. F of 1.5. So whatever 1.5 squared plus 2 is. Has anyone done the math or do I get to do it? 1.5 squared is 2.25 plus 2, 4.25. Next one we've got to find is f of 2. 2 squared plus 2 is going to be 6. And we've got to find f of 2.5. 6.25 plus 2, 8.25. How many rectangles did I have? 4. How many links did I just find? 4. Does that make sense? And do you see why I did not plug 3 in? Okay, it does not have a rectangle that forms on that point on the line. Okay, that would be a different type of rectangle. So those pieces right there are the lengths of the rectangles, or if you want to call them heights, whatever. So our job was to find the lower sums, yes? So for notation, since this is area under a curve, this is a sum. My notation is S of L. And they just do that because it's indicating we're using lower sums as opposed to upper sums. The first rectangle is a half wide times how tall? 3. So a half times 3. The second rectangle is what? A half wide times 4.25. The third rectangle is a half wide times 6 tall. And my fourth rectangle is a half wide times 8.25 tall. Now, that is the only time I'm going to write it out like that. What was in common on all of those? They were all a half, weren't they? What you will normally see me write is I will put the 1/2 out front, the width of the rectangles out front, and then in the parentheses it's going to be the lengths added. So 3 plus 4.25 plus 6 plus 8.25. Mathematically, that's easier to plug in on the calculator, isn't it? Because you can add those, multiply by 0.5.
2150. Well, I can't think right now.
Half of 20 is 10. What's half of 1.5? 75. So 1075. This is area under a curve. I don't have a label, so I'm going to say 10.75 units squared. Yes, I wrote out a lot of work. It was our first one also. You're usually going to see me write out a decent amount of work. I may shortcut some of them, okay? Now, this was lower sums. All of my rectangles were under the curve. We'll talk when we get to the back side. This also happens to be an example of left rectangles because where do all these rectangles start? On the left. Okay? Questions on that one? I mean, the idea behind it's not bad. It's really not. So, okay, you ready? Let's try 2. This time, okay, note the details. We're going to use upper rectangles to estimate the area under the curve y equals negative x squared plus 9 on the interval 1 to 2 when n is divided into 5 rectangles. So, needless to say, I'm going to draw that first quadrant view because that's what really matters here is that first quadrant view. It's a parabola moved up 9 but flipped upside down. So basically what I'm going to draw, I don't know if I can make this, let's see, 3, 4, 5, 6, 7, 8, 9. So it goes from 9, it's upside down. I'm going to draw it over to where it intersects the x-axis. Oof. I probably should have drawn that a little bit larger. That's all right, we'll make it work. Can you guys figure this out? Where's it going to intersect the x-axis? At 3. Okay. And again, you know. Okay, so we're going from where to where? From 1 to 2. Whoops. Did you get the indentation in the paper? I can't really. So that means from 0 to 1, doesn't really matter. From 2 to 3, doesn't really matter, right? We're looking in between here. Five rectangles. Skinny things. So, I know. That's why I said you kind of have to. So we need 5 rectangles. If you're trying to figure out how wide, can you guys figure out? It's from 1 to 2, which is a unit of 1. So we're dividing it into fifths. Okay. Again, the official, you can do endpoint minus endpoint, 2 minus 1, divided by 5, which is 1/5. If you want the decimal, that is 0.2. Okay. Sorry, I kind of had to make my marks at the bottom because once you draw the line, there's no going back. Mine are going to be too. Oof, that's. Mine, I don't think mine's a whole lot. I don't know. Maybe mine's a little bit better than your guys because I know what I'm trying to do, but they're not the greatest. But that's all right. Okay. Now, what matters? First of all, we need to know these bottom points. This is 1. Where's that? The edge of that first rectangle then? 1.2. What's the next one? 1.4. 1.6. 1.8 and 2. You have to be able to find those points, right? And that's just adding the 0.2 on. What kind of rectangles are we drawing this time? Okay, it's upper rectangles. That means your rectangle is the edge or top of your rectangle is outside of the curve. Last time, they were under the curve, so our estimate was on the small side. This time, my rectangles are going to be outside of the curve. Now, that means you could be left side endpoints or right side endpoints. But how do I make a rectangle outside? If it's going to be upper, I have an endpoint at 1, going over and down to 1.2. I have an endpoint at 1.2. Goes over to the right, goes down. Do you see how I'm making these upper? 1.4, 1.6, and 1.8. Again, which number happens to not be being used? The 2. You always have one number not being used. One of the endpoints, most likely. I guess I gotta be careful about saying always. Now, can you guys tell where these endpoints are? This is at 1, right? That was at 1.2, at 1.4, at 1.6, and at 1.8. So what do we need to find? Yep. Plug those numbers into the equation. It's f of x equals negative x squared plus 9. So we need to find f of 1, which is the negative of 1 squared plus 9, which means 8. We need to find f of 1.2. So the negative of 1.2 squared plus 9. This is where you grab the calculator, and the calculator's doing the work, right? I have 7.56 if you want my number. You plug in 1.4 next. Negative of 1.4 squared plus 9. I have 7.04. Plug in 1.6. Negative of 1.6 squared plus 9, 6.44. And then I plug in 1.8. Negative of 1.8 squared plus 9, 5.76. Do I have the right number of heights or lengths of my boxes? We had 5 subintervals. I should have 5 values. That's kind of your check. Like if you go on to 2, oh, Fred, I got 6. I only need 5.
So we want to go 2 decimal points then.
That's what I have written down. I guess technically if we're talking the Saxa book, it'd be more than that. Honestly, a lot of them end up being whole numbers, if I recall. Or they go fractions. I guess because I have a fraction on the next one. Okay, I'm going to say S of U this time because it's the sum of the uppers. How can I, what is the sum of the plugging into my calculator? Out front, I'm going to have, what is my width? 0.2. So it's going to be the 0.2, which is my width of all the rectangles, times, what do I do inside the parentheses? Add up all those lengths, right? 8 plus 7.56 plus 7.04 plus 6.44 plus 5.76. I have written down 6.96 units squared. Okay. I have to push because I would like to hit, honestly, it's one of those days I would, for various reasons, I'd like to hit kind of every problem to an extent. Okay, you guys ready for example 3? Use lower rectangles, 6 subintervals to estimate the area under y equals negative x squared plus 2x on the interval 0 to 2. Okay, it's upside down. We need to know a little bit more than it's upside down. We have to know a little bit of what it looks like here. If I factor this, if I take negative x squared plus 2x and set it equal to 0. If you factor this, you can factor out a GCF of negative x, and then what am I left with in my parentheses? X minus 2. If I set each of those equal to 0, I'm going to get x equals 0 and 2. What is that 0 and 2?
That's your interval.
It's your what? Well, it happens to be my interval, but more importantly, on my graph, since those are my zeros, my solutions, those are my x-intercepts. And I'm doing that because it can help me graph it. Now, can you graph this on the calculator and specifically look at the interval 0 to 2 and see what it's doing? Yeah, you can use your calculator to help you. But I'm also trying to get you guys to think through it. So my point is, Riley already said it's an upside down parabola. If it intercepts at 0 and 2, and our range is 0 to 2, basically we're looking from intersection point to intersection point. Okay? So let me get you a graph. So we know there's an intercept at 0, and there's an intercept at 2. So, and we know this is upside down. So what that means, it's my parabola is doing something. You guys can't see my pieces there, like this, where it's upside down from 0 to 2. How wide is each rectangle going to be?
Too small.
My interval is from 0 to 2, and we're breaking it into 6 pieces. So 2 minus 0 divided by 6 is 2/6, or a lovely 1/3. So we're taking from 0 to 2 and breaking it into 6 pieces. Can you guys do this? So I need zeros are right there. 1/3. After 1/3 is 2/3. After 2/3 is 1. What is 1 1/3? 4/3. So what is 1 2/3? 5/3. And then 6/3 are 2. Okay, guys. The reason why I wanted to look this one, it's different. What type of rectangles are we doing? Lower rectangles. So our rectangles all have to be under the curve. So you can't go from the left every single time. Can we go from the left some of the times? Yeah. So here's the deal. It's lower, which means sometimes my rectangles are going to go from the left in this case. Sometimes they're going to go from the right. If we go right here, wait, let me start between 1/3 and 2/3. Let me skip over the first one. I'll backtrack. If we go from 1/3 to 2/3, where do I draw the rectangle so it's under? You draw it on the left from 1/3 over to 2/3, yes? Between 2/3 and 1, how do I draw the rectangle so it's a lower rectangle? You draw it from 2/3 over. How do I draw a rectangle from 0 to 1/3 so that it's under? And if I start from 1/3, it's going to be over. So I have to start from the left. So we're going to be using 0, which means that rectangle has a height of 0. It's an estimate, guys. In other words, is lower rectangles the best estimate to use in this case? Absolutely not. Okay, but it's what we were told to do. Now, what about between 1 and 4/3? Where should I draw that so it's a lower rectangle? This time we're going to go from the right side from 4/3 over. Between 4/3 and 5/3, you're going to go from 5/3. And between 5/3 and 2, you're officially going to go from 2. I feel like we're moving fast, but we're moving slow all at the same time. Is that possible? Again, you're using that equation, right? If we plug in f of 0. What are you going to get out? Well, you can plug in 0 if you want, but mathematically, it's 0. If we plug in a third, officially I would keep this in fraction form. It's the negative of a third squared plus 2 times a third. So negative 1/9 plus 2/3. So negative 1/9 plus 6/9, which is 5/9. If I do 2/3, the negative of 2/3 squared plus 2 times 2/3. Negative 4/9 plus 4/3. So negative 4/9 plus 12/9, which is 8/9. What if I say I'm not going to do the math for 4/3, but I already know it? What did you guys tell me? What is f of 4/3? Don't do any math. 8/9. Why? Is this symmetric? Can we assume some symmetry here? Yeah. On my drawing, I get it. But I mean, think about it logically. We're at the halfway point in between 0 and 2. There's got to be a vertex there. Okay. So what's that mean about f of 5/3? 5/9. And we already figured out that f of 2 is going to be 0. So in order to do my sum of my lowers here, what's the width of all of these? I hope not.
Yeah.
I didn't skip anything. What did you guys skip?
We're going from 0, 1/3 to 4/3.
0, 1/3, 2/3.
We just skipped one.
But we don't have a rectangle using 1. I'm using dot, dot, dot. No dot here. Dot, dot, dot.
Instead of using 2 for the right. Okay. I'm sure I can.
I used 6 values, but instead of not using one of the endpoints, I didn't use the 1. Are you okay with that?
Yeah, it's just checking.
I get it. It's different. And this is why could I have skipped this problem? Not really. Okay. So 1/3, and then you're going to be adding 0, 5/9, 8/9, 8/9, 5/9, and 0. So it's 1/3 times 26/9, which is 26/27 units squared. Is there a decimal equivalency? I'm sure there is. Do I know what that decimal equivalency is? No. Do I care? No. Okay. We're going to have to fly through the back. Okay. The front was up or lower, yes? You kind of have to decide how we draw these. The back is left and right. It's not really deciding. They tell you, you use the left or you use the right, period, end of statement. So left rectangles, notice at the top it says, start on the left, move to the right. Right rectangles, start on the right, move to the left. Midpoint rectangles, start in the middle. That's fun. Move to both sides. Okay. Now, example 4, it says repeat example 2, but use right rectangles instead of upper. So I'm going to have to redraw that picture so you have it in your notes. This is the negative x squared plus 9. So it's the parabola upside down. Nine on the y-axis, goes at 3 on the x-axis. Remember, the important parts are between 1 and 2. Because it was the interval 1 to 2,
It's green.
and it was n equals 5.
It's green.
Not green.
It was green.
It was.
I swear.
Oh yeah, it really was.
I saw briefly out of the corner of my eye that my screen went green, but it's not green. Okay. So again, remember it's 2 minus 1 divided by 5. This is the one where it was 1/5 or 0.2. So this is the one where I had those pieces drawn in very, very carefully. This is the one where I think this is where Jack described it as a drunk drawing. I'm not sure mine looks much better. These lines are 1.2, 1.4, 1.6, 1.8. What's a right rectangle mean? Start right, move left. So I'm going to start at 2, draw it over. I'm going to start at 1.8, draw it over. I'm going to start at 1.6, draw it over. I'm going to start at 1.4 and draw it over. I'm going to start at 1.2 and draw it over. Which number does not get used? The 1. Okay, this is also equivalent had they told us to do lower rectangles. This is lower rectangles. Happens to be. Now, I'm just going to write down the pieces. So we need to know f of 1.2 is the first one. Well, hey, guess what? It was 7.56 earlier. We need to know f of 1.4, which is 704. We need to know f of 1.6, which was 6.44. We need to know f of 1.8, which was 5.76. We need to know f of 2, which we didn't have to use before. So it'd be negative of 2 squared plus 9. Negative 4 plus 9 is 5. So when I designate this one, this is the sum using right. So you'll usually see it denoted S of R. What's the math you have to do? Okay. It says add them all up, divide by 5. I was going to write it down as add them all up and multiply by 0.2. Same idea, right?
So what are we dividing by?
Well, you can either divide by 5, because it's multiplying by 1/5, or multiply by 0.2. So if I say 0.2 times the sum of those, 7.56, 7.04, 6.44, plus 5.76, plus 5. I feel like it's annoying that I write these all out, but on the flip side, if you look back at this later, I want you to know where the calculations came from.
I got 6.36.
You got it. 6.36 units squared. No, it's not a huge deal. I don't remember if I ever take off for
I
it.
keep answering and circling it, and then I hear you go units squared, and I'm like,
Yeah.
So it's not like plus C.
No. And on AP, I don't even know that they make you label. I can't remember. So. Okay, example 5. This time it's repeat example 3, but use left rectangles. So if you want to know, example 3 was the bottom one we did. Y equals negative x squared plus 2x from 0 to 2, where n was 6. So this is the one where I need to draw. We get to see the whole upside down parabola, right? It intersects the x-axis at 0 and 2. It's supposed to be symmetric. Does that help if I say that this time? And if you recall, we're breaking it into thirds, right? Because 2 minus 0 divided by 6.
So these people consider like upper also.
No, because they're lower and upper.
Joe. I did the wrong one.
Okay, so my directions say, did you guys draw your picture? I drew in my 6 boxes. I haven't set them up, done my left piece. But so I have 1/3, 2/3, then my 1, 4/3, 5/3. And then we end at 2. Now, officially, these are left. So that means not just upper, it's just you start at left no matter what. So the left endpoint, the first left endpoint we start at is 0. So that's that height of 0 again. We start at 1/3. We start at 2/3. We have to start at 1. What's going to happen when we start at 1? It's going to go out and up. It's going to be an outside rectangle, an upper rectangle. What happens when we start at 4/3? It's upper. And what happens when we start at 5/3? It's upper. So in this case, because we were told left, we have a mixed boat. Okay? You're going to have to know f of 0, which is 0. F of 1/3, which is 5/9. F of 2/3 was 8/9. F of 1, you officially have to find this time, and it's 1. F of 4/3 was 5/9. F of 5/3, wait a minute.
Yeah.
F of 4/3, sorry, I reversed it, was 8/9. F of 5/3 is 5/9.
Not do that because on the right they're taller and over, but on the left they're under.
But it's still that number. It's just that last time we drew 4/3, it went under over here. So my 4/3 was over here is what was happening. This time the 4/3 is over here. So it's the same height rectangle, different location.
Oh.
Does that make sense?
Yeah.
Hello. Okay. Bye. Okay. Officially, you guys know what to do here, right? It's 1/3. You add all these up. It becomes 1/3 times 35/9. You get an answer of 35/27. And Cassidy is going to tell me units squared. Sorry. Well, here's the deal. I'm down to 4 minutes. I haven't talked about example 6 yet. You guys know to do all the adding there, right? I'll fill it in later. Okay.
No, we don't got to.
Okay.
Leave her out.
I know what Not everybody. This is what we're going to start class today. Normal homework, which is Wednesday. E-learning is a math Excel assignment, so I'll start doing the same stuff. Okay? Sorry. Okay. Now, this time, it's cosine, midpoint, 4 subintervals, 0 to pi over 2. So, cosine, if you think about cosine,
It looks like example 39.2. We're at 2 minutes, 30 seconds. Go.
Okay, cosine starts up at 1, yes? And we're going the interval from 0 to pi over 2. Well, pi over 2 happens to be where it crosses through the x-axis. So it's kind of like a corner of a parabola again. Okay? Cosine? Cosine goes like this, right there, is pi over 2. Okay? That's cosine. Now, interval, guys. It's pi over 2 minus 0 divided by 4. So it's pi over 2 divided by 4, which becomes pi over 8. So when you set up these intervals, and we need 4 intervals, right? In the middle is pi over 4. What's half of fourths? Well, that's pi over 8. So down here I have 0. Then my first mark is pi over 8. My middle mark is pi over 4. And then what comes after pi over 4? 3 pi over 8. Because it's 1 pi over 8, 2 pi over 8, 3 pi over 8. And then pi over 2. Now, we need mids. Mids means, are you ready to watch my picture? My points are in the middle of each section. Which means, it's easier to draw it over here. My rectangle is part lower, part upper, it's kind of like. Because my rectangle goes through that height right there. And it's really hard for me to show it on this first one. Does that make sense what a midpoint does? Now, midpoints, you would have to know that half of 8s, this would be pi over 16, 3 pi over 16, 5 pi over 16, and 7 pi over 16. You would figure out, you would do the normal rest, okay? We may have to talk about a midpoint sometime. I can tell you the answer, if you want it, 1.0065 is what I have written down. You would plug it in your calculator, make sure you're in radians.
What was that on this SM?
I said SM because it's sum of the midpoints. Almost got through it.
If it wasn't for home.
Well, I still would have been cutting it. I was still cutting it close. I will finish writing the stuff in, and actually I'm still recording, so if you...
Hey, Jackson, maybe you should be here next time, eh?
No, Jackson, you just got called out. We'll see if he listens to this video or not. And you'll notice, guys, if you're still kind of paying attention, when I write these in, I'm just writing it as cosine of these things. I'll punch it in my calculator all later. E-learning, come Monday with questions on your worksheet. Okay? Aubrey, you need something, don't you? Whoops.
Sergeant, I'm going to go get your book and read it back to you.
Sounds like a good plan.
Oh, I was the first one in here. Let's go. Look at the food. Where are my sandals?